Let us discuss about the embedded C basics programming. So this is the ability enhancement course for 4th semester. The course subject code is 21EC481. So there are 8 experiments you need to conduct and 3 demonstration experiments. So let us do one by one. So you need to download Keil Microvision. So if you go to keil.com/download, then product. So search for Keil downloads. So again, in the products downloads, you're going to get C51 version 9.61 December 2022 version. So this is a development tools for all 8051 devices. So once you download this, it will ask for some registration and all. You can give actual correct data only. Otherwise, you can give some random data and you can download. Once you download, you will get a desktop icon. So I'm going to open the tool now, Keil Microvision 5. By default, you're not getting any window here. Sometimes it will open previously closed projects. So you need to create new project. The procedure for this one is I'll show how to program using Keil. So once you download, by downloading C51 software here shown, so it provides, actually you have to purchase a license, otherwise the code is limited to 2 kilobytes. Okay, it's a student version. So you can, if your code is less than 2 kilobytes, then only you can execute that program. Otherwise, you need to purchase that license. So after that, you need to go to project and click on new Microvision project. Then give some name. And after that, you have to select 8051 device. You can select microchips Atmel 8089C51 that I will show you. After that, you have to add the startup file also. Okay, I will go one by step now. So here, go to project, new Microvision project. So you can save all your projects in one folder. So you can create one folder in documents or C drive or a D drive or E drive. So somewhere you create, I'll create in the documents. Okay, in 8051 I created. In the 8051 already one project is there. So don't mix, I can create one more project in the new folder. Create, right click there, create a new folder, and you can write 8051. Okay, or you can give your name, BH, like that I will give. So inside that I will create my project. You give project name as your name. Okay, I'll create Raghunath, or you can create project one, or like that you can create. So this is I'm executing Keil Microvision 5 version of software. If you are using old one, you may get different file project files extension. So after that, it will ask for the device for the target. So here you have to select. You can type 89C51 here. 89C51. If I type 89C51 from this company also, you are going to get one. That is ISSI, and microchip companies also 80 Atmel 89C51 also you are going to get. And next piece also you are going to get. Okay, now here you select microchips 89C51. You can see the description. 8089C51 is 8051 based fully static 24 MHz CMOS controller with 32 IBAR lines, 2 timers slash counters, 6 interrupts slash 2 priority levels, and built UART 3-level program memory lock, 4 kilobytes of flash memory, 128 bytes of RAM. So this you have to select, click OK, and it will ask for copy startup.a51 to project folder. So click on S here. So once you click here, you can see the left side project window. Project name is Raghunath. Here target is 1, and this is a source group where you have to add all your source files here. So if there is still plus mark is there, you can expand this. So just now it is added one startup file once you create a new project. Now we have to write a code for these programs. So the syllabus, you can see some 9 programs are there now. You can execute one by one. So let us start with any one program. Let me execute 8051 to find sum of first 10 integer. Okay, I'll do this one later. Write 8051 C program to find sum of first 10 integer. Okay, already programs are already I typed. So right click here. You have to add new item to group source group 1. Click on this, and since we are adding C file, click on C file here. Click on C file, and you can give name it as sum of 10 integer. Sum of 10 int, like that you can give. Automatically it will add extension .c. Just give the name sum of 10 int. Click add. See here automatically .c is added here is extension. So here I can type the program here. Otherwise, I already have the typed program here. I'll explain what is that program. So first, like since we are using C programming, we have to include a register header file. Okay, so for 8051 family, there is a header file called reg51.header file. reg51.h. So you have to include that file. Hash include reg51.h. This is required since we are writing a. You selected the device as 88 89C51. So we have to include corresponding header file for that particular device. Void main, we are writing a main program, open bracket. So we are declaring two variables, sum I. Okay. So unsigned char is a data type. Okay. The sum is of type character type. So unsigned char, these are keywords. The blue color and all, they are keywords. Once you save it as a .c, so all the keywords are actually coming in blue color. So unsigned char sum is equal to 0. We are initializing sum is equal to 0, and sum is actually of type data type char. Similarly, one more variable I, it is also type char. So you can also write here only sum is equal to 0 comma I also you can write, so that you can avoid one more extra line. That is your choice. You can write both sum and I in the same line. Sum is actually initially assigned to 0. Some initialization is done to 0, but I, we are not doing any initialization in the declaration. So unsigned char I. So each line in the C program should be ended with the semicolon. Otherwise, at the compilation, it will give error. Okay, now we are writing for loop because we have to add first 10 integers. So here for I is equal to 0, I less than equal to 10, or you can write less than 11. Less than 11 means it will include 10 also. Otherwise, once that I value becomes 10, it will not add it. Okay. Or you can write less than equal to. Okay. Here I less than 11 you have to write. Otherwise, I less than equal to 10. So here already we declared I as a character type. Initialization of I value is 0. For I is equal to 0. If I less than is equal to 0 and I plus plus. So you know the syntax of for loop. So this is the condition. If I less than equal to 0, you have to execute whatever code written in within this bracket. After this I plus plus should be done. Again, you have to check that condition. Again, if it is true, execute this statement and you have to continue until this condition is true. So once you keep on increasing I value, first initial value of I is 0. First it will add sum is equal to sum plus I. You can write sum plus is equal to I, or you can also write sum is equal to sum plus I. Okay, or sum plus I is equal to I, sum plus I is equal to initial, that one is also correct, this is also correct. So initial value of sum is 0 and we have taken I also, initial value is 0. Okay, so it is going to add sum is equal to sum plus 0. So we are adding starting from 0, otherwise you can give I is equal to 1 also. Okay, first it will add sum is equal to sum plus 1. Initially sum is 0, 0 added with I value 1. Okay, now new value of sum is 1. After that I plus plus will takes place. Next it will check whether I is less than or equal to 10. Okay, if the condition is, because increment value of I is 2 now, 2 is less than 10. So again it will execute sum is equal to sum plus I value. Previous value of sum is actually 1. Now 1 is added with 2. So now new value of sum is 3. So like that it will keep on adding some. First it will add with 1, next 2, next 3, next 4, next 5. Once I value reaches uh, uh, equal to 10, it will do. Okay, if the condition is true, it will do less than or equal to 10. Now once it equal to 11, this will not execute. So at that time what it happens, in the accumulator the sum value will be stored, and simultaneously there are some ports are there in the 8051, port 0, port 1, port 2, port 3. You can send the values to ports also. So let us check the output now. First, once you write the program, okay, this for loop, don't write semicolon here, because this is the syntax of for loop. If you write semicolon here, this will not execute. So for I is equal to 1, I less than equal to 10, I plus plus, don't write semicolon here. Open bracket, close bracket, inside that what you have to write, that you write. After the completion of for loop, the answer will be still in sum. So you have to assign that sum to accumulator. In the accumulator, you have to pass that value to sum value to this accumulator and also to port 0. So that is left to you where you are showing your output. You can show it in through ports, or you can store it in some memory location, or you can store it in accumulator, some registers you can store. So now I'm compiling. Next step is you have to build target. Okay, this is the build target F7, or you can click this special function keyboard. No, F7 I can also press, or you can click this. You check for any errors. If there is a errors, it will show error, and error line number also it will show. Here you can see the line numbers, and in which line the error is there, that will also it will show. And here no errors, no warnings also. So now you have to start debug. You click on this is a debug. Okay, see, I already told it is a evolution software student version. Your running code limit is actually 2 kilobytes. This is actually, even if you write some hundred of lines of codes or 500 lines of codes, your code will be less than 1 kilobyte only. Only if it crosses 10,000 line or 1 lakh line, then only your code will be more than. Okay. So small programs you can execute. Click OK. So it will go to here. So it is startup file. And this is your sum of 10 integer file. Your cursor will pointing this point. So that means you have to execute step by step. Now if I execute step, this point, the pointer pointing to this line, now this is going to execute. Okay, and you can also see what are the variables you used here. Some we used here, character I is used, accumulator we not know, accumulator and all you can see here. This inside 8051 we have accumulator, register B. Okay, SP is stock pointer, DPTR means data pointer. This is stock pointer max, program counter, and PSW stands for program status word, where it will indicate different flags: carry flag, auxiliary carry flag, then overflow flag. This is parity flag. So here we are interested only about if there is a carry. I think in this program we are not using any carry because we know where we are written about the carry. So in the coming programs, we also take care. We have to read what are the status of these flags. All are single bit. Okay. If any carry is generated, this bit will be 1. If overflow occurs, this bit is 1. If there is odd parity, 1 parity, based on that, this will be for, I think, even parity 1 or even, this will be 1. And these are the registers: R0, R1, R2, R3, R4, R5, R6, R7. There are 8 registers. All are 8 bits. All are 8 bits. 0x stands for hexadecimal. So 00 means hexadecimal 0, hexadecimal 0. In terms of binary, 4 zeros are grouped into single 0. Again, 4 zeros are grouped into 00. So 00 means 8 number of zeros, because it is written as 0 hexadecimal 0. Hexadecimal, if you convert into binary, you have to split each hexadecimal into 4 bits of binary. Similarly, the maximum value it will hold is FF, where all 8 bits are 1111, 1111. So 1111 is F, again 111 means F. So here the size of each register is, in 8051 it is 8 bit, and 8051 is 8 bit microcontroller. So now we have to execute step by step. So for that you can open here watch window is there, you can see here watch 1 and watch 2 is there. Here call stack window is there, register window is there. Okay, now it is not visible. If you click this, it is visible. Symbols windows is there. You can see all these things. If you don't want, you can click this. Command window is not required, assembly is not required. You open call stack window. Okay, important thing is you have to open call stack window, and if you want, you can open watchdog watch windows also. Okay, now you can adjust this width also. See here, it is not visible. All the variables, local variables are not visible. So you can here this much space is left. So you can drag this. You can go here. So now you can see in our program we are using sum and I, and both are visible here. Sum value, I value. Okay. Now we will execute one by one. First, it is going to execute this. So there is a step and there is a step over. So anyone you can click. So better use step over. Okay. If it is step for loop and all, it will take entire this. It will take so much of iterations you have to do. Otherwise, once you do step over, it will finish one line of execution fast. So now I'm going to click step over. F10 also you can press. See, sum is initialized to 0. Previously also reset value of reset a microcontroller, all the special register, all register contents will be 0 only. So sum is 0, and uns and char I is also 0. So now these two are executed. So now the pointer is showing here for I is equal to 1, I less than is equal to 10, I plus plus. So first value of I is 1, I is initialized to 1, sum is 0. So first sum is going to added with 1 value. So now the sum should show 1 here. If I execute, see, first step, first it is going to execute with I value is equal to 1. Okay, see the value of I here. I value is 1. Now sum value is 0. You can see sum right side, you are going to get 0. So sum is added with 1 now. So click step over. So now you can see still that this is not added. Sum is equal to sum plus is not added. See here, this is not executed. You can see the value of I. I value is now change it to 1. Okay, I value is changed to 1. Right side you can see 1 value. Sum is 0. So once you execute this, sum value here it is going to change it to 1. 0 plus 1. Now click step over. Now you can see sum is 1. Now after this I plus plus will takes place. After the end of this for loop, this will execute I plus plus. After that it will check for this condition. If it is less than equal to 0 or is less than equal to 10, okay, again it will execute this. So I plus 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 take. So you can see I value is now 2. I value is now 2 because I plus plus and I value is less than 10. So it is true. It will execute. Sum is still 1. Now it is adding with 2. So now new value of sum is 3. And after that you execute next. Again I plus plus will take place. Now I value is 3. Okay. I value is 3. And sum is previous answer 1 plus 2 is 3. New value of I is also 3. Now sum is 3 plus 3 is 6. It will come. Okay. Note that this is hexadecimal. Okay. So after that again now I value is 4. 6 plus 4 is 10. In hexadecimal 10 is equal to 0a. See 0a. Again I plus plus will takes place. I value is now increased to 5. Now a plus 5. That is 10 plus 5. 10 plus 5 is 15. 15 in hexadecimal is f. So we're getting f. Similarly, next 6 I value is 6 and now it is added like that. Sum is added with increment values. Okay, see here. Once the I value, what is the I value? You can see I value is 0a. So still it is executing that. So now the answer is 37. Okay, 37. Now see I value is b. B means 11. So it is greater than 10. So it will not go here. So it will come out of this for loop. Now the for loop is over. So now we have to assign that whatever this variable is actually holding the value of some value. That some value should be assigned to accumulator here. See already accumulator is having 37 and we have to send this one to port also, port 0. So here click. So you can see in the accumulator, this is accumulator. A means accumulator, B means register B. So in the accumulator 37 is there. In 37 is equivalent to 37 is equivalent to 55. Sum of first 10 integer is formula is n into n plus 1 by 2. You put to 10 into 10 plus 1 by 2. 10 into 11 by 2. So divide 10 by 2 is 5. 5 into 11 is 55. 55 in decimal is equivalent to uh, 55 is equivalent to 37. So your answer is coming here. Okay, that is the first program. So I will show you how to verify your answer. Sorry, not here. Your answer is coming here, no? 37. Sum is coming as 37. See, I value is B, that is 11. That's why it came out of the loop. So you have to verify the answer in the port also. Go to peripheral. I bar O port is there. So we are sending output to port 0. So it is case sensitive. You have to type capital P0 only. P and 0 is, this is not O, P0. So go to port 0. In port 0 also, once you execute, it is not still executed. Still arrow mark is here, pointer. So once you execute, this 37 also will come here. So 3 and 7. So hexadecimal you have to divide off. These 4 bits for left side, these 4 bits for right side. So 37. So 0011 is 3. 0011 is 3. 0111 is 7. So 37 it is hexadecimal and in decimal it is equivalent to 55. This is sum of first 10 integers.